In this video, I will show you how to create a NEO4J Aura graph database, which will contain a part of our data for our hospital system chatbot. And very briefly, let me show you some of the advantages of graph databases compared to relational databases. First of all, graph databases are known by their simplicity in modeling real-world relationships, reducing the need for complex schemas based on multiple join operations. It's easier to handle complex relationships. Graph databases are more flexible as they are schema-less, so they are easier to adapt when there are changes in data structures. Also, retrieving information is much faster when querying graph databases, especially in scenarios involving complex queries. And last but not least, the support of pattern matching makes it easier to find specific structures within the data. Now, let's see how to create our graph database. First of all, you need to go on NEO4J website. I will put the link in the video description. You just need to click on Start for Free. You will be taken to the account creation page. Here, you just need to create your account by putting your email address, password, and so on. Once it's done, you will find yourself on the instances page. We create a new instance, we choose for free, and we choose a name of our instance. Let's call it Hospital Chatbot. We create the instance, and you will be given a password that you will be asked to save somewhere, so don't forget to save it in a safe place. Once it's done, our instance will be starting creation. Once it's done, you will see your instance running here. As our database is empty, so we see nodes 0, relationships 0 for now. And if you open the file where you saved your instance information during installation, you will find information like these: the Neo4J URI, username, password, and so on. We will need this information later to query our graph database. Now, once our instance is up and running, we need to insert data in it. But before that, let's understand the data that we will insert in the database. Here we have what we call flowchart, which shows us the relationship between nodes, edges, properties, and so on. As you see, our nodes are patient, visit, payer, hospital, physician, and review. Here are the edges which relate nodes to each other. For example, we have patient has visit at a hospital which employs a physician, and the physician treats the visit. This is an example how you can see the relationship between nodes. You have the review written after visit, and the visit is covered by a payer. And of course, each of the nodes and relationships have their properties. For example, here we have the nodes properties. For the visit, it has its ID, admission date, and so on. You have name, school, and other properties for the physician. For the patient, you have name, blood type, and so on. And you have the other properties for the other nodes. We have properties for the relationships as well. As you see here, relationships have ID as unique property, except covered by, which has billing amount and service date. It is to be mentioned, guys, that this is a fake database, so we don't have much information. But in a real case databases, you have far more nodes and relationships between them and more properties for both. Now, guys, we need to populate our graph database. You don't need to code anything from your side, as you already have the code. So if you haven't uploaded it yet, you can find it in the beginning of this tutorial that I will provide the link in the video description. So it's here in the very beginning of the tutorial. You can download the code by clicking on the link, or if you go directly to the step 3 where we are now, you can find it in this section. Upload data to Neo4J and you find the link to your code here. So let's suppose that you've already downloaded your code. For this video of this series, we need the source code step 3, as we are in the step 3 of the series. In this folder, we have the data folder with the CSV files, and we have the hospital NEO4J ETL folder where we have the source code, we have our Docker file and PyProject file. We also have the .env file where we put all the needed information for our database population. We have the Neo4j URI, username, the password, and so on. Also notice that we've stored the CSV files in a public location on GitHub because AuraDB instance is running in the cloud and it can't access files on your local machine. And you have to use HTTP or upload the files directly to your instance. Also, we have the PyProject file where we have configuration, metadata, and dependencies. Now, if we go directly to the main file, which is hospital CSV write, in this file we import necessary libraries, we read env variables that contain data path and Neo4j information. We define our logger and you create a list of nodes that contain our 6 nodes. After that, we create this helper function that creates and runs queries, which enforces each node to have a unique ID. Last but not least, we have our main function, the load hospital graph from CSV. As you see, it's decorated by a retry mechanism here. In the function, we instantiate a driver to connect to the Neo4j instance. We set the uniqueness constraints that we defined above, and we load the hospital nodes from the CSV files. As you see here, we precise the attributes as well, and we do this for each node of the graph. So we have hospitals, payers, physicians, and so on. After that, the relationships are loaded the same way. I leave you parse the file by yourself, guys, and don't hesitate to ask me questions if you have any. Now, if we go to our entry point file, it's actually not technically necessary for this project, but it's a good practice when building containers because it allows to run necessarily shell commands before running the main script. Last but not least, we have the Docker file where we put the work directory. We copy the source file in that directory, we copy the PyProject file as well, and we install necessary packages in this file. If we check its associated Docker Compose file, we see that it contains only one service that we called hospital Neo4j ETL, which will run the Docker file in this directory using the .env file. Here we don't need a Docker Compose either because we don't have many containers to orchestrate, but this will be more helpful once we have more containers. Now you need to run your ETL process by running this command, docker compose app build. Once it's done, you will see these log messages where it's written setting uniqueness constraints, loading hospital nodes, and so on. So the same logs that we've put in our code, and it means that our data is loaded in our graph database. Now let's check this in our instance. So here we have our instance. If I go back to the main page, we see that our instance is running, and now we have 21k nodes and 48k relationships. To visualize it, you need to click on connect, go to query, and we will have a dashboard where we can query our GraphDB. And as you see here, we have our nodes, relationships, and all the properties. Now, the language that we need here, guys, to query our Neo4j DB is called Cypher, which is the equivalent of SQL in relational databases. Let's try some queries in Cypher to get familiar with the language and to visualize a little bit our graph database. Let's start with our first query, which is this one. So we need to put it in this field. In this query, we are matching on patient node. Here we are adding an alias to patient so that we can use it later in the query. And we are limiting the output to 5. So here we are telling Neo4j to return us the first 5 patients in the database. If we run this query by clicking on this run button, here we see that we have our 5 patients. This is the graph visualization, but we can visualize the table as well. And here we have our first 5 patients in the DB. And as you see here, we have attributes of each patient. So here we have his name, sex, blood type, and date of birth. Let's try out another query, which is this one. So here we are matching on the visit node, and we are adding a condition where the visit ID is equal to 56. If we visualize it in table, we see that here we have all information related to this visit, and as you see, the ID is 56, and we have all the information related to it, including admission date, discharge date, and so on. So this helps us to return all information related to the visit with ID equals to 56. Now let's try out this query where we use two nodes. So here the query search for the patient that has a visit with visit ID equals to 56. As you notice here, we have both nodes and we have the relationship between nodes, and we have the direction of the relationship here with this arrow. If we go back to our flow chart, we see that the patient has a visit and not the other way around. So if we chose the other direction, it wouldn't have worked and we would have nothing as output. So here we have our output, and if we check the table format, we see all information related to the visit and the patient where the visit ID equals to 56. Now imagine, guys, that we want to have information related to the physician, guys, who treated this patient at this visit. So this query will be changed this way, and we add physician on the other side. And if we go back to our flow chart, we see that the physician treats the visit. So that's why we have this direction here where the physician treats the visit. If we run this query, we have the information that we asked for. All information related to the physician, the patient, and the visit, where the visit ID equals to 56. So to summarize this query, it asks NEO4J to look at all patterns where the patient had the visit by the physician and where the visit ID is equal to 56. This is amazing, guys, isn't it? Now, before finishing the video, let's try out two last queries. The first one is this query. As you notice here, we have a relationship with no direction with respect to visit or n. So what this query tells Neo4j is to look for all relationships that go in and out of the visit 56, along with the nodes related to these relationships. Let's run this query, and here we see what we asked for. We see that we have the relationship at with the node hospital treats physician. So here's the same that we used in the previous query, and we see that it's the same physician here. If we check our last query, so it's the same physician, and we have all the other relations like covered by, has, with their associated nodes. This is crazy, guys, how it facilitates running queries and reading results compared to relational databases. And imagine how this becomes more powerful, guys, especially when we want to add more information or more nodes, like to record nurses, pharmacies, drugs, and so on, or any other valuable information. This would be very easy to add to the graph compared to a relational database where we would have added more joins between tables, and it would have needed complicated queries to return information. Now let's finish our video with a very last query where we try out aggregation. So this is our query that returns the number of visits and the total billing amount for visits covered by Aetna payer and which took place in Texas. That's why here we are matching on hospital for the state name. If we run this query, here we have what we asked for, the number of visits and the total billing amount. So here what happened under the hoods, we match all visits and are covered by a pair. We then filter out the result by a certain name, which is Atna in this case. Atna is the name of the pair. We precise it by the P alias here, and hospitals with state name equals to Texas. After that, we count the number of the matched patterns and we sum up the billing amount to have the total billing amount. And here we have our result with the number of visits and the total billing amount. This is it, guys, for today. In this video, we saw how to create a NEO4J AuraDB instance. For our graph database, we saw how to connect to the database running in the cloud. We populate the database and how to query the database using the Cypher language. I hope you guys like the video. In the next video, we will see how to put it all together to build our graph RAG chatbot. Don't forget to subscribe to the channel and to ask me questions in the comments if you have any, and see you next time.